Here's a quick example of calculating how much I have left of sample. So I'm going to use that sample 131 iodine again, because I can remember what the half-life is. Half-life for that was 8 days. So what I would like to do is find out how much is left, or after one half-life, two half-lives, and so forth. So plugging into the equation, I might remember that n is defined as the time divided by HL, which I'm using as half-life. So let's say one half-life, that'll be 8 days. So n equals 1, when t is equal to 8, that is n equals 8 divided by 8 days. That's 1. So that'll give me a percent remaining, which is what that term is, of 1/2 to the 1 power. Now if I make it n equals 2, percent remaining will be 1/2 squared. N equals 3, there's supposed to be a 2 there. Percent remaining will be 1/2 cubed. So this one's going to be 1/2 of a half, which is a quarter. And this one's going to be 1/2 of a half of a half, which is 1/8. So we can kind of see the half-life formula here. We're going to count literally 1/2, 1/4, 1/8, 1/16, 1/32, and so forth. The reason that we cast this in this base of 1/2, and that is the base right there, the reason we do that is because it's easy to count. It's easy for us to look at these things and say, well, I know what it is when n equals 1, then it's a quarter, then it's an eighth, then it's a 16th, then it's a 32nd. It's easiest for us to count that way, and that's why we leave it in that 1/2 format.